Good morning, everyone. Myself Devika, working as assistant professor from the Department of Electrical and Electronics Engineering at the Sri Muthukumaran Institute of Technology. Today, we have learned about the subject on W25C01, Basic Electrical and Electronics Engineering for second semester as per Regulation 2024. Today, I'm going to present about the series and parallel circuits, which is an important topic in basic electrical and electronics engineering. In this presentation, we will understand series circuits, parallel circuits, equivalent resistance, voltage dividers, and current dividers. Series circuits. These are circuits in which components are connected end to end. So they share one common node and no other component is connected to that node. An important point is the same current flows through all components. So two resistors are connected across the voltages. So the total resistance is uh, R1 plus R2. So then series circuit example is here resistors R1 and R2 and the connected across the voltages Vs or connected in series. So the source current is equal to the current through each resistor. That is, Is equal to I1 equal to I2. Then parallel circuits. Parallel circuit is a circuit where components are connected side by side. So they share two common nodes. That means the voltage across each component is the same. So the example of a parallel circuit, in this circuit, resistors R1 and R2 are connected in parallel with the voltage source Vs. So the voltage across each resistor is equal to the source voltage. That is, Vs equal to V1 equal to V2. Then series resistance. When resistors are connected in series, their resistance add directly. So R1 plus R2. So the equivalent resistance is given by R equivalent equal to R1 plus R2. So the another name is equivalent resistance or effective resistance or total resistance, all the same. So this means series connection increases the total resistance. Then parallel resistance. In a parallel circuit, conductance add instead of resistance for two resistors connected in parallel. That means R1 and R2 is connected in parallel. So the equivalent resistance is calculated using 1 divided by R equivalent equal to 1 divided by R1 plus 1 divided by R2. Parallel connection always gives a resistance less than the smallest resistance. So if you have two same resistor values, the total resistance is half of the one resistor, half value of the one resistors. Now I'm going to present about the voltage and current dividers. Voltage dividers. In a series circuit, the applied voltage is divided across the resistors, proportional to the resistance. So the same current flows through all resistors, and according to Ohm's law, V is equal to I into RE. This principle widely used in voltage divider circuits. Voltage higher resistance gets more voltage and lower resistance gets less voltage. So voltage dividers are commonly used in sensor circuits and reference voltage generation. So the formula of voltage division rule, So the voltage across the particular resistor is equal to total voltage divided by sum of all resistance. So total, in general, the voltage across in a across one in a series of resistors equal to the total voltage into resistor of the resistor of the particular divided by sum of all resistors. For example, now we have to find the voltage across the resistor R3. So we have to find V3 equal to total voltage 16 into particular resistor value 300 divided by sum of all values. So we have to find the V3. Then current divider. In a parallel circuit, the total current divides among the branches proportional to conductance. Since voltage is the same across resistors, current depends on resistance. So current divider formula, the current through one of the two parallel resistors is given by the current divider rule. That means the lower resistance carries more current, higher resistance carries less current. So the formula of current division rules. So the current through the particular resistor equal to total current into resistor of opposite resistor divided by sum of all resistor. For example, so three resistors are connected in parallel. So now we have to find the current through the 200 volt. So I1 equal to total current through the particular resistor equal to total current I total into opposite resistor. So opposite resistor is R2 divided by sum of all resistor R1 plus R2. So solve this, we have to find the current I1 current through the 200 ohm resistor. General current divider, if one branch contains a combination of resistors, it can be simplified first. Using conductance, the current divider rule can be applied to any number of parallel resistors. Conclusion. To conclude, we have studied series circuit, parallel circuit, equivalent resistance, and the voltage and current divider rules. These concepts are very important for circuit analysis and problem solving. Thank you.